and we take a look at a Python program. This is a piece of code. This is a little script. If you type this into the code, take this code, Python code, into a file and ran it, it starts at the beginning, and then it goes to the next line, and the next line, and the next line. And Python executes the scripts as you write them. So it says stick a variable to, find a place called in your memory called x, stick 2 into that, okay, then go to the next one, print that out. So the program is producing output. Now go read x and add 2 to it and stick it back in x, so x is 4, then print that. This side over here, this is called a flow chart. I'm not going to make you draw flow charts. I'm only going to draw them a few times that in ways that I think will help you. But you can think of it as Python, when it finishes something, it goes on to the next one, unless you tell it otherwise. Finishes this, goes on to the next one. Finishes this, goes on to the next one. Finishes this, and now the program is all done. And so that's sequential steps. You just type them in, Python runs it. They're important, but sort of uninteresting, because you can only get so far. And you can't really make them intelligent because it's always going to do the next one. So the next thing we do is what are called conditional steps. And this is where it starts to get intelligent. I mean, where you are able to encode your brain into the computer. Like, oh, wait a sec, let's only do this step if something is true. And the syntax that we tend to use here is the reserved word if. Okay? And so the if is like a little fork in the road. You can go one way or you can go another way, and you're asking a question. So inside the if statement, right here, there is a question saying, is x less than 10? That resolves to a true or false. If it's less than 10, that's true. If it's greater than 10, it's false. And so then what we do is, if it's less than 10, we have this indented block of code. There's also this colon that tells us we're in the beginning of an indented block of code. And so what it basically says is, if this is true, run that code. If it's false, skip that code. So it can either run it or skip it, depending on this question that's being asked. Now, if you look at this code, it's pretty obvious what's going on. It comes down, x is 5. If x is less than 10, that's true. So it runs this code and prints out smaller. And then it comes back here, it de-indents the next basic sequential. This ends up being kind of a block. If x is greater than 20, if x is greater than 20, oh, come back. If x is greater than 20, this turns out to be false because x is 5, and so it skips this. So the bigger never comes out, and then it continues on and prints fini. Oops, that's a typographical error. Make that a lowercase print, and then prints fini. So it comes in, runs this, skips this, and then finishes. Okay? So here is the last one we'll talk about, the repeated steps. We'll get back to store and retrieve later, but for now we're just going to talk about 3 of the 4. This is another program, and the key is that we're going to use this same choice where we're going to go in, but then we're going to run for a while, and then we'll have an exit condition where we get out. So this is a repeated over and over and over and over again, and this is the essence of how we make computers do things that are seemingly difficult, well, that are more naturally difficult for people. Okay? And so how do we encode this notion that we want to do something for not forever, but for a while? How do we encode that notion? And so we do it in this way. So we have our statement, sequentially go to this while. While is a keyword, and it's asking another question that's a true-false question. Is n greater than 0? I read this as long as n remains greater than 0, keep doing this indented block. And you have a colon at the end, and then you have 2 lines of code that's indented. So that tells us what the loop is, and then this is now de-indented. And so it comes in, and if this is true, it runs these 2 lines. Prints out n is 5, and then it says n equals n minus 1, which makes n be 4, and it goes back up, and it goes up and it asks this question again. Is n greater than 0? If it is, continue on and prints 4 and then subtracts it, and it does that. 4, 3, 2, and prints out 1. Then it comes up, and now after this, n is now 0, and n is no longer greater than 0, so it takes sort of the exit ramp and goes down here. So it takes the exit ramp and goes to here and runs the next line. Now, we're going to cover all this again. So I'm just trying to give you the big picture. Next couple of chapters, we're going to hit all these things again, and we're going to hit them in much more detail with a lot better information. This is now sort of like combining these. And again, I don't want you to really like know this stuff. Just you will know this in a couple of weeks. You will see this program again. But this shows you how we combine those patterns of repeated, sequential, and conditional together. And so this is a bit of sequential code. Comes in here, runs this, which happens to ask for a file name. Then it opens the file. It creates a data structure called a dictionary. This is all sequential. Now the for is another form of loops. So this is going to loop for a while. And then this is within a loop. We can even have two indents, and that's another loop. So these are like repeated. And then it goes down to the next sequential bit. Then it does this. Here's another loop that's going to run, and then here's a conditional that's going to run. And then when it's all done, we print out the last thing. And this is, of course, is the program that does, it figures out the most common word and prints that most common word out. And so this is a Python short story. It reads some data. It reads the name of a file. It opens that file. It talks about how to make a histogram. And then it looks through for the most common word. So don't worry too much about this. Over the next couple weeks, we'll fill in the pieces so that you absolutely understand every single line of this code. So, this is a quick overview of Chapter 1. Stick with us. You realize it will be Chapter 7 before this makes too much sense. You really have to trust that you are learning important things and that it all makes sense when we bring it together like in Chapter 7 in a few weeks. Hello, and welcome to Chapter 2. Now we're going to continue to talk about the building blocks of Python, variables, constants, statements, expressions, etc. The first thing we have to talk about is constants. These are just things, we call them constants because they don't change. They are numbers, strings, etc. And we use them to sort of start calculations, or if something is greater than 40 hours, we're going to do something. And so 40 is the constant in that situation. So we have 123, we have 98.6, we have hello world, which is a string by enclosing it in quotes. We pass each of these things to the print function, and a side effect of the print function is that we see the output. So print 123, prints out 123, print 98.6, prints it out. So these are just really the syntax of constants, and without constants we can't write really much of anything. The other sort of foundational notion of any programming language are the reserved words. And like I said before, reserved words are these special words where Python is listening for them, and there are very special meanings. So when Python sees if, it's not just any other word, it means how Python implements conditional execution. Variables are the third building block, and that is a way that you can ask Python to allocate a piece of memory and then give it a name. And you can put stuff in that. Sometimes you just put one value. Later we'll see when we do collections in chapters 8 and 9, we will see that more than one value can be put into a variable. And the variable, how we control the variable is through the assignment statement. And as I said before, it's important to think of the assignment statement as having an arrow to it. So this is not saying x for all time is the same as 12.2. What it's saying is take 12.2, find a place, find some memory in your computer there, Mr. Python, give it a label x, we get to choose the x. That's the variable part. We chose it, right? And then stick 12 in it. And then the same is true for 14. Go find another spot, name it y, and then put a 14 in there. So think of this as an arrow every time you see that equality, the assignment in an assignment statement. Now, these variables hold one value. So now if we have these three statements, these two, and then the third one executes, it says put 100 into x, but that wipes out the old value of 12.2, and it rewrites it with 100. And so we can change the variables. That's another reason that we call them variable. There are some names. Now, there are some rules for making variable names. You can start with a letter or an underscore. We tend not to, as normal programmers, use underscore. We tend to reserve those for variables that we use to communicate with Python itself. So when we're making up a variable, we tend not to use underscores as the first character. You can have letters and numbers and underscores after the first character, and they're case sensitive, but it's really a bad idea to use case as the only differentiator. So in this case, spam eggs, spam23, and underscore speed are all totally legit. We would probably not use this one unless we were actually doing it because Python told us to use that variable.